So we have discussed right the concept of interfaces. Interfaces are similar to classes, which are lacking the instance variables. Methods are only be declared. The implemented class must redefine all methods of that interface. The next one is nested interfaces. Interfaces can be nested. One interface can be defined with respect to the scope of another interface, like a nested class. One interface can be the one interface can be the member of right another interface, or one interface can be a member of another class, right? That is said to be a member interface or nested interface. Nested interface can be declared as a private or public or protected one. The thing is, the top level interface must either be declared as public or use the default access. When you access something right outside the scope of that interface, when the interface is nested, then to access the inner interface, you need to use the outer interface name. Like outer class name tries to access right the inner class name, right, using the name concept. So here you need to use outer class outer interface name, then you need to access the corresponding inner interface or outer class name dot inner interface. Have a look into this code class 1. The class 1 is defined. Here some instance variables are declared, right? These are missing. Then interface 1 interface. This is a part of one class. Here the interface is a part of a class. Now this is to be a nested interface. Or an interface can be declared a member of another interface, outer interface. Now, assuming that one interface declares one method int a find absolute int x for the given integer parameter, let us try to find out the absolute value. So that is the role of this inner interface. Class 2 implements this interface means since this is an inner interface, this should be referred using the outer interface name. Outer interface name dot inner interface name, or outer class name dot inner interface name. What is outer class name? Outer class name is 1. So using that outer class name 1, 1 dot 1 interface in inner interface is accessible. Here, right, the inner interface method is redefined. Public int find absolute int x, checking if the value of x is 0, formal parameter, using a ternary operator. If it is less than 0, the value minus x is returned, else x is returned. So we are trying to find out the absolute value of the given integer. Now, having this class interface 11, you try to create an object of this to then using this object you can directly call the find absolute. If not, if you like to create the class reference variable, right? So one dot class reference variable, right? Not possible. Interface reference variable, one dot one interface. Since one interface is accessible using outer class name or outer interface name, one dot one interface name is value. One dot one interface, then reference variable. This is equal to new implemented class name. Implemented class name is 2. Then using this one ref right as a reference variable, we can call find absolute. For example, we are calling find absolute of 100 and find absolute of minus 2. So finding the absolute value of integers 100 and 200, 100 and minus 200, that results in 100 and 200. Java C interface 11 Java Java interface 11 100 and 200. Understand? So the important thing is we are trying to create an interface reference variable for inner interface. This will be referred by outer interface or a class name. So 1.1 interface. This is a valid access. Then reference variable is equal to new implemented class name. Then using this reference variable, you can point the corresponding interface methods. Say find absolute. So one ref dot the find absolute. Then next one interface 12. We have discussed in JDK versions, right? Later, recent versions, JDK 8 and 9, right? Some additional implementations are given. Default interface methods. Some default definition of the interface method can be provided in JDK 8, right? So the corresponding method is to be extension method. This is of course a new capability to the given interface. We can define a default implementation for the interface method. So in that stage, the abstract definition is removed, right? Normally, return type, method name, parameter list, right? So when you specify return type, method name, parameter list, that should be preceded by a keyword default, right? Default, that is a keyword. This is useful to define the interface method as a default method. So that stage, right, the method declaration semicolon is removed and you can provide the corresponding method definition. Default method name parameter list, then provide the definition of the method. In JDK 8 also, right, it cannot have the instance variables. Interfaces still lack instance variables. The class can maintain a static information, but the interface cannot maintain a static information. It is not possible to create an instance of an interface by yourself. You cannot create an instance or object corresponding to the interface. As we discussed earlier, interface I1. I1 I object is equal to new I1 that results in a compile time error even in the recent versions of a JDK. So remember that the default method of an interface should be provided like this. Default return type, method name, parameter list provide the definition of a default method. For example, we defined the default interface in which right one interface method is declared get principal and one default method assuming that the default interest rate, right? For example, 0.7 is given, 7%, right? Default interest rate is given. In this stage, right, what happens means default interest rate return 0.7. So in case if you want to call the get interest rate means the default value, right? The 7 is returned. Then is the default method returns a value 0.7, 7 by 10, right? Not 7 percentage. Now a class fixed deposit implements a default interface. Public say get principal return 1000. What is get principal? The method, right? This is an interface method. This interface method tries to return a value 1000. Then public void public double get interest rate return 0.8. If you want to override the default version, that is possible here. Public double get interest rate 0.8. Now let us assume that this method has been overridden method has been commented out. Then for default interface, one reference variable is created. Default interface depref is equal to new implemented class name, a fixed deposit. We are trying to call this one simple interest. Principal into right say n into r interest rate. Now defref dot get interest rate. Defref dot get interest rate. What happens? Since in the implemented class fixed of the deposit, defref dot get interest rate. This is not redefined. So the interest rate right 0.7 is taken. Java C interface 12 Java interface 12 1400. So it seems the interest rate is taken as 0.7. By overriding the get interest rate, that is a default method is overridden here. In this stage, if you call get interest rate, what will happen is the overriding version is taken. Now compiling and running 1600. So the overriding version, this version is taken. So if you fail to redefine the default method, by default the default version is going to be called like a default argument parameter in C++. If you wish a default value, right, a parameter, default value of the parameter is taken. Likewise here, methods may be provided some default definitions. In case if the implemented class is missing the default definition, default version is called. If the implemented class is overriding the default version, the overriding version is going to be called. This is the concept of extension method or a default method defined in JDK 8. Next, see there are certain issues in multiple inheritance. Default methods to support multiple inheritance behavior, right? Suppose two interfaces I1 and I2 are defined. Interface I1 defines its own default method, I1 save. Interface I2 defines its own default method, same method name. Have a look into right method name. Void f, here also void f. But the definition is changing. This is I1's f and I2 defines its own method, right version, I2 save. Have a look into this new class I1, I2. Class I1, I2 implements I1, I2. The class I1, I2 tries to implement the features of both I1 and I2. So public void f, in this case, we are given the message I1, I2's overriding version of f. Now creating an object of I1, I2, and you can call the version here, right? You try to check, right, what happens. Or I1 ref is equal to new I1, I2, then call I1 ref dot f. Try to see, right, what is actually printed. I1's version or I1, I2's version. I2 ref is equal to new I1, I2, then calling I2 ref dot f, right? You try to check which version is going to be called. Here, this is the class implementation. Class implementation takes a priority over an interface default implementation. So in this case, running interface 13.java interface 13 calling the interface overriding method using I1 ref or even I2 ref. This overriding version takes more precedence. So surprisingly, you can see the method I1 I2's overriding version of f. Second call also I1 I2's overriding version of f. So far we have discussed that interface reference variable can have the rights to call only its own method when that reference variable is assigning the implemented class object. Same way here, I1 ref is equal to new implemented class object. Perfectly okay. I2 ref is equal to new implemented class object. But here, after this I1 dot f, I1 ref dot f means this will not call the actual version available in I1. This is very important and you will get a surprising result because I1 ref dot f means assuming that f is also defined inside the class I1 I2, but f is said to be a overriding version. So in this case, when I1 ref dot f means this overriding version is called, right? So this takes more precedence. So I1 ref dot f calls the overriding version of f, then I2 ref dot f, this also calls the overriding version of f available in I1, I2. So try to learn this in case of a multiple inheritance, right? So implements I1, I2, the class implementation overriding version takes more precedence than the actual default implementation of the interface. This is a rule. Then interface 14. Suppose right in the same example, interface I1, a default version is given, interface I2, that same default version is given. In class I1, I2, implements I1, I2, assuming that no overriding default method, because the class implements I1, I2, The previous example we have overwritten the versions available in I1, I2. Here we are failing to override interface I1's version and I2's version, assuming that I1's and I2's type signature are the same. In that stage, right, the implemented class fails to redefine the overriding version of I1 and I2. That is a default void f, right? You must have provided here public void f, similar to, right, the previous example. Public void f. This overriding version is missing. In this case, compiler which reports a compile time error. See how will be the compile time error is reported. Class I1 I2 inherits unrelated defaults for F from I1 and I2. So the version F, right, which is inherited from both I1 and I2 is not overriding in this I1 I2, right? So this version is not overridden in I1 and I2, which means that overriding version of both the defaults F in a single version is required in I1, I2. Since we are missing that results in a compile time error. In case if overriding is given means using the class object or interface reference variable, class overriding version takes the precedence. Next one, interface 15. Extending interface issues. Suppose interface I1 defines, right, one default method void f, another default method void g is given, right? Two default methods are defined in I1. Interface I2 extends I1. Here, right, you have provided say default methods void f, void g. What is inheritance? Accessing the features from the superclass or accessing the features from another interface. Here interface I2 extends I1, right? So default void f, default void g, what will happen means this interface I1's version is overwritten in I2. That means I2 version overrides the version available in I1. Then assuming that in the implemented class void g, right, no overriding of default method g, right, what happens, g is missing here. Then what happens, only f is overwritten, public void f system.out.println I1 I2 is overriding version of f. Then we are trying to call I1 ref is equal to new I1 I2 I1 ref dot f, then I1 ref dot g. One person is overriding, f has been overriding, but we are missing the overriding version of g. Now what happens, let us check the result. Interface 15.java java c interface 15.java java interface 15. See I1 I2 is overriding version of f. First call I1 ref dot f. Since overriding version is provided, what happens, overriding version of f is called. Then I1 ref dot g. I1 ref dot g means here what happens, I1 ref dot g. G is given here. I2 g overrides I1's version. So in this case, right, I2's go, sorry, I2's g. So you can see the message I1 ref dot g means implemented class object is I1 I2. I1 ref dot g means what happens, this overriding version is taken I2 g. So second line we can see the method I2 g. Likewise here I2 ref is equal to new I1 I2. I2 ref dot f means I2 ref second interface, right, dot f. F means, right, clearly the overriding version is called overriding version of F. Then I2 ref dot G, but G is not overwritten, right? So in that stage, what happens? Inheritance. Here, this version is overridden into this G. So this version is implemented in class I1, I2. Again, you can see the message I2 switch, right? These are the issue chain interface inheritance. If one interface inherits another, with both defining a common default method, then the inheriting interfaces version of the method takes precedence. So using the interface reference variable, we call the overriding version means, right? This overriding version is called. If you call the version, right, which is not overwritten, in that case, what will happen is the extended interface versions, that interface, right, overriding version is taken here. Then interface 16, extending interface is used, right? In the same code, you try to see in interface I2, defining right default void F. What will happen means when the interface I2 is implemented in I1, I2, calling F or G, the version available in I2 is called. In case if you like to call the version available in the super interface, right? The interface which has been extended from, right? I2 has been extended from I1 to call that actual I1 interface F method. You need to use this syntax. Interface name dot super dot method name. So interface name is I1. I1 dot super dot F. I1 dot super is valid because extends I1. I1 dot super to call G, right? You have to use this. So in this case, here if no overriding default method is given, void G is given here, then what happens means the G which is available in the second interface I2 is taken. That stage, the interface method G tries to call the super interface version G method. So it seems that I1's G followed by I2's G. But calling F, right? You are calling I1 dot I1, sorry, I1 ref dot F means the overriding version of F will be called. So running the code, interface 16, Java interface, sorry, interface 16. First I1, I2 is overriding version of F, right? Because of this message, I1 ref dot F, overriding version of F. I1 ref dot G means here G is not defined. G is actually defined from the second interface I2 because I2 overrides the version available in I2. But calling I2 dot G, what one I2 I1 ref dot G means this version is calling. This first tries to call the superclass version. So I1's G, then I2's G, second like I1's G, then I2's G. Then using the second reference variable I2 ref dot F means I2 ref is pointing the implemented class. So you can see the message I1 I2 is overriding version of F in the next line of output. Then calling I2 ref dot G means here G is not overwritten. So G is actually taken from interface I1 I2. Since I2 is overriding I1, so this version is actually calling. This version first tries to call G's version available in I1. So it seems that I1's G followed by I2's G. These are the issues available in extending interfaces. Few more examples. Interface 17. You can provide some static methods in an interface in the version of the JDK 8, right? Similar to static methods in a class, you can provide some static methods in the interface. In that case, right, what you have to do means No implementation of the interface is necessary. Static methods, right, need not be implemented in the interface. To call a static method, right, no instance of the interface is required. Simply, right, you can call using the interface name. Interface name dot static method name. Static interface methods are not inherited either an implementing class or a sub interface. Right, this is a rule. Static interface methods are not inherited in the implementing class or even the sub-interface. Right? No inheritance is allowed for static interface methods. A simple example, have a look into their interface I1. One interface method is declared getChar and one default interface method is defined. Suppose it returns a value 100. Static int get constant return a value 0. Simply write this is the static interface method, right? Static interface method is similar to the default interface method where the keyword default is replaced by static. Then a public static interface implements I1. In that case, right, assuming that one method h is defined, you can directly call getChar, get int, and to access the static method, you need to use this general form. Interface name dot static method. Interface name is I1. I1 dot static method name is get constant. In case if this is a default, we can directly call as we did here get int. Since get constant is a static method, this can be accessible using the interface name. As we have already discussed, the static methods like parse int can be accessible simply using the class name itself, right? The class name dot parse int. So here, what we have to do means interface name. Interface name is I1. I1 dot the corresponding static method name is get constant. I1 dot get constant. In main method also, right? If you try to call I1 dot get constant, that is okay. But I1 dot get char, I1 dot get int will not work because get char, get int are not static methods. H is a non-static, sorry, H is a non-interface method using the object of static interface. We are trying to call a method H, and we are calling further the static methods using the interface name I1 dot static method. Interface 17 Java C interface 17 dot Java interface 17 S100 00, right? So this is S. Then H, right? This is S. Then 100, 100. Then finally, right? I1 dot get constant returns a value 0 0. Then last one interface 18. We can also have some private interface methods inside the interface, like static interface method, static return type method name parameter list type definition, as we provided in the last example. Interface 70, static interface methods, right? Here default interface methods. You can also provide private methods in interfaces. It seems a different one. JDK 9. After the JDK 8, right? The version JDK 9, right? Following JDK 9 versions. Interface can include a private method. For example, here we can make it as private int get constant something, private int m1 something. The methods are completely private methods. This can be called only by a default method or another private method of the same interface. Suppose one interface, right, I is having two private methods, right? The two private methods can be called by using a default method. Since the method is interface method is private, this cannot be accessible outside the scope of the interface in which it is defined. So only within the scope of that interface you need to access the private methods. So private methods at any stage are not inherited by the sub interface. In case when multiple default methods try to access a common block of code, the common block of code can be made as a private method so that the private method can be accessible inside the default method. For example, in the given array, given the start value and the end value, you try to find out the number of elements in it, right? Or you want to display the number of elements in it. This is one task. Given one integer, suppose x. After that integer, you try to find out the number of, you try to find out the listing of some numbers in between the starting and the ending range. Anyhow, in two scenarios, we are trying to commonly find out the numbers or commonly displaying the numbers in between starting and ending range. So the code to find out displaying the starting and ending range, right, in the given array is a common one that can be made as a common private method so that this private method can be called in some of the default methods of the interface, right? So it can be called only by a default method or another private method of the same interface. So with respect to some real-time situations, we can have the private interface methods. But to check the private interface methods, you will have installed JDK 9 or later versions of JDK 9, right? So I have JDK 8 right, in that version, right? I cannot check the accessing rule of this one, having a private interface methods. So just to have a concept, private interface methods are possible. Private interface methods are better called in the default interface method so that a common block of code can be reused in some of the default methods. Thereby, we are reducing the code redundancy. Duplicate code can be avoided, right? So for that purpose, private interface methods are used. If you have any queries, right, you can ask. Please go through these interface documents, right? If you have any queries, please ask me.